Right, this lesson is the last lesson in your statistics topic. It's called quantiles, or how to use a function on your calculator called InvNorm or inverse normal. So I'm going to review what you did last lesson, which was normal CDF. The normal CDF function on your calculator tells you the percentage of data in a normal distribution that lies between an upper and lower value. This is a diagram here of what normal CDF finds. It tells you how many percent is shaded in this area that sits between a lower and an upper boundary. That is what normal CDF is finding for you. Inverse normal, on the other hand, is like the opposite of that. Inverse normal on your calculator, the situation is we know the percentage, I know what this is, and I want to know where the boundary sits. That's what inverse normal does. So, once again, let me remind you, normal CDF is finding the percentage if I know the boundaries. This last function that you're doing for statistics, it's the inverse of that. I know the percentage, I'm trying to find the boundary. So I'll give you a couple of minutes to get this done. Get your graphics calculators out, please, so you can test out this function. And those recordings, all that screaming, it sounds like a prison. Or a childcare centre, which technically we are. I just don't clean your poopy nose. It's literally the only thing I do. Yes?
Is it just the same as all the other ones?
Yes. So when, because you got the older one, it's, you put the area in as a decimal,
Yeah.
comma this,
Yeah.
comma that.
Cool.
Thanks. I'll move this over to the side so you can get down. Well, you still need, I just want to show you live how to access inverse normal. It's in the same place that you've accessed normal CDF. What do? You press second vars, and 3. The third one is inverse normal. I have an older calculator that I'm demonstrating this on. So all I see is this. If you have a newer calculator that says something about a tail, I have instructions for you right at the end, okay? You're slightly advantaged by that, okay? Just for now, while you're listening to my explanation now, if you have a newer calculator that says something about tail, can you just set it to left for now, so you can follow along with us? So when you open that, and if you're on the Casio calculator, you'll see something that says inverse normal, area. What is the area? This is that percentage or probability of the distribution, but as a decimal. So 0.5 would be 50%. This symbol here is the mean. That symbol there, the circle with a little haircut, this is the standard deviation. Please notice that I don't get to set upper and lower like normal CDF anymore. So what you need to keep in mind is if you've got the old calculator, or if you've got the new one and you set the tail to left, what is that tail referring to? That's referring to the area that you're colouring in. What direction is that going? Left or right? Left. It's going to the left. So if your old calculator says this, like mine on the board, or if you've got the newer calculator and set it to the left, your area, whatever you put in, is going to go to the left. And inverse normal is telling you where that line sits. That's what inverse normal is doing. Normal CDF, you tell the calculator where the line is, normal CDF finds the percentage. Inverse normal, you know the percentage, you're trying to find where the line is. Okay? And you get that board down. And just be aware, if you're finding to the left, what are you finding? You're finding an upper boundary. Because the lower boundary is like negative infinity in the left direction. Okay? So a couple of minutes to get that. We'll do an example, and then I can shut my mouth for the rest of the day. Can I have a quick show of hands who has the newer calculator that says something about tail? You have. See, I need to show all of them because I think the calculators that we have, if you don't have one, that the school has, I think they're the old ones. So I'll show you literally every. Okay, this would be much less notes if everyone had the same calculator. Yeah, what I'll do is I'll move that over to this side so that the camera can capture the example and you can start taking down the example. Check if that's still recording, because if it's not, it'll be up. All right, what is this little section about? There's like a little added complication here. Your inverse normal, if you have an older calculator, that's the only way it works. It only colors in to the left. But that's telling you the bottom X%. That's telling you what is the highest number that would be in the bottom, 25%. But you're gonna have questions that say, what value does the top X% lie above, okay? What is the lowest score that the top 20% of people that took the exam get? Where would I be coloring in if I wanted the top X%? I'd be coloring in that way. My tool doesn't work like that though. So what I've said here, and I'm going to demonstrate it to you, is normally inverse normal only lets you find the upper boundary of an error. It only lets you find this. You need to think about it when questions involve a lower boundary. So my question to you, if this was the top 20%, can you think what lower percent is going to end up in the same place? What if this is the top 20%, how many percent is below? 80. So if your tool can only color in to the left, and your question says, I want to know where the cutoff point for the top 20% is, well, I need to do it backwards. I need to do the inverse of it and go, well, that's in the exact same place as the bottom 80%. You sort of need to rework the question for yourself if you have an older calculator, okay? If you have the little tails thing, you'll be fine. You can get around that, but most people don't have that calculator. So what I'll do is, let's go through an example together. A recruitment agency tests its workers' typing speeds. The results are normally distributed with a mean of 40 words per minute, standard deviation of 16.7. What percentage of workers types faster than 50 words per minute? I like to chuck this in Because normally what I do is when I teach you something, we just do questions on them straight away. Is part A asking you to use inverse normal yet? Does inverse normal find the percentage, or do you know the percentage and then you're finding? Yeah, so this isn't an inverse normal question, it's just a normal CDF one. It's what we did last time. What percentage of workers types faster than 50 words per minute? Can someone remind me how I access normal CDF? What do I press? Second vase. Select normal CDF, which is the second one. I want to answer this question. What percentage of workers types faster than 50 words per minute? So all I'm going to do is type in, no, actually can't go up there, faster than 50 words per minute. So I'm interested in that. So what's my lower boundary going to be? Huh? No, where's my lower boundary? This here? 50. Lower, it's going to be 50. Now I need to do that weird thing. The upper boundary, where's the upper boundary? It goes on freaking forever, right? So I need to do that E99 thing. Or if you're on the Casio calculator, just press 9 until you're happy with it. What was the mean? It was 40. So these people are pretty slow at typing. 16.7. How do I show the working for that really quick? I go normal CDF 50 E99 40 16.7. Therefore, what's that as percentage? 27.47%. Faster than 50 words per minute. Okay? A little review of last time. Now let's answer B, which is inverse normal. If the slowest 10% of workers are forced to take a typing course because they're so slow, what is the fastest typing speed of someone taking the course? Am I given the percent here? So now I'm using inverse normal. I'm not trying to find the percent. So second vase, inverse normal. Because I'm finding the lowest 10%, my tool does that. It colors in to the left. So what would 10% be as a decimal? 0.1. What was the mean? It was 40. The standard deviation was 16.7. So that's telling me the fastest person in the bottom 10% types at 18.6 words per minute. Okay, that's the cutoff point, which is quite slow. And you can sort of imagine that there. Well, okay, 40 was the mean, right? 50% of the data lies there. Where's the bottom 10% going to be? Down there. It's quite a ways down. Okay, so how would I show the working for that? InvNorm 0.1, 40, 16.7. What does that spit out? 18.6 words per minute, rounded to 2 decimal points. Slowest 10%. Last question, if the fastest 5% of workers are prioritized, so they get jobs, they get placements because they're so fast, what is the slowest you can type and still be in the top 5%? So this is the opposite situation. Does my tool allow me to color in to the right? What have we established here? It doesn't work that way. So what percentage is below the top 5%? 95%. So if I wanted to work that out with the old calculator, I'm going to go second vase, inverse normal. And because my tool doesn't support what it's finding, I need to flip it. What's the opposite of 0.5%? 5%, 95%. So I'll go 0.95. Enter, 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 67. So C InvNorm 0.95, 40, 16.7 equals 67.47 words per minute, rounded to 2 decimal points. That's how you use that to a question?
If I have a newer one, I can use the right.
Yes, so that's what. If you've got a newer calculator, I don't need to explain it for the video. If you have a newer calculator, you can take advantage of the fact that you can set the tail. You can tell it where to color. If you set it left, then it works just like the old one. If you set it right, what could you do? You could go 0.05 and then right, and then you'll get the exact same answer as this. Okay? Please don't use center. I've tried to work out how it works, but I can't. Just leave it alone. Okay? Just go left or right. These are little diagrams to show what left and right means. But other than that, your homework now, which is the end of statistics to end of EX. I think it's 5C. Let me check. Yeah, 5C. 5C and you're done on statistics. You're revising for the rest. Get on to it.
You change the test date to week 6, right?
No, the